In this tutorial, we're talking about how work is further related to energy. We said that work creates energy, but we have not really given any kind of an equation that shows that relationship. So the way we're going to start this is we're going to look at our equation for work. Work is FD times the cosine of the angle in between. And just for the ease of calculation, we're going to say that our direction of motion and the direction of the force are the same. So that gives us an angle equal to 0 degrees, and the cosine of 0 is 1. So anything times 1 is itself. And so we're just going to ignore that cosine for this derivation. So we're going to look then at another equation from back in the beginning of the section, which is the final velocity squared equals the initial velocity squared plus twice the acceleration times the displacement. And what we're going to do is we're going to solve for the acceleration times the displacement. We're going to solve for that value there. So we subtract vi squared on both sides, and we have vf squared minus vi squared is equal to twice the acceleration times the displacement. Now to get rid of this 2, we divide by 2, which is the same as multiplying by 1/2. So I'm going to multiply each side by 1/2. And then we have 1/2 vf squared minus vi squared is equal to the acceleration times the displacement. They cancel out over here. So we just have a difference in our notation here, but d is the same as x. They mean the same thing. So we can write it as a times d if we'd like. It's just a difference in how we represent that value. So now what I'm going to do is force is mass times acceleration. So that is m times a, according to the second law of motion, times our displacement d. And looking at a times d over here and a times d over here, now what I'm going to do is replace this one with 1/2 vf squared minus vi squared. So the work is the mass times the quantity 1/2 vf squared minus vi squared. It's kind of getting a little convoluted here, so we're going to just rewrite that equation and simplify it. We said mass times the quantity 1/2 vf squared minus vi squared. And now we're going to distribute the 1/2 to both v's and distribute the mass to both v's. And so that gives us that the work is 1/2 times the mass times vf squared minus 1/2 times the mass times vi squared. What we see here is that this is our equation for kinetic energy. This is the final kinetic energy, and this is the initial kinetic energy. So we have that the work is equal to the change in kinetic energy. And so that is our relationship for the work kinetic energy theorem. The net work, and it's the net work because we said that the force is equal to mass times acceleration. That's only true of the total force, the net external force. And so we would have to talk about the net work if we talk about the net force. That just means the total work. So the total work done on a system, on an object, is equal to its change in kinetic energy. This relationship is true even if there's friction. So it doesn't matter if there's friction or not, this relationship would be true.